All right, just like yesterday, there are a couple new terms. So for 15.4, there are 4 new terms. There are not going to be any for 15.5 because we won't have learned them all by then. So 4 new note cards for 4 new words. Just like yesterday, I'm going to show you the actual definitions, kind of explain it to you, and we'll be done with our circle terms. So before we get started, you need 4 blank note cards. All right, and we're going to start with a tangent segment. Okay, so now it's not a full tangent. It's a segment of a tangent line with exactly 1 endpoint on the circle. So now it's just a segment. So DC is the tangent segment. So pause that video if you need to. I'm going to flip tangent segment because I definitely know I didn't give you enough time to copy that. So pause so you can copy this. Okay. The next word is secant. And by the way, 15.4 is going to be talking about segment relationships. So a secant is any line that intersects a circle at exactly 2 points. So A, B. And notice it's a line. We've already talked about a chord in the past. If it didn't have this line going through it, A, B would actually be a chord. So we'll talk about chords as well today. So the other side of this is just secant. Okay, now we also have a secant segment. I do not have a picture of this. It's just part of a secant line with at least 1 point on the circle. So I'm actually just going to go ahead and draw it for you. So it's like if I had a say it kept going there. A B would be a secant segment. It's also a chord. Yes, it can be both, but it's part of a secant line at least one with at least 1 point on the circle. Secant segment. Okay, and last is an external secant segment. A secant segment that lies in the exterior of the circle with 1 point on the circle. And it's not a picture there, but we are going to draw one. An external secant segment. Let me grab my paper to remember what an external secant segment is. I sometimes get confused with the external secant segment and tangent segment, but okay, an external secant segment will be when you have secants that meet on the outside of the circle. That's an external secant segment. Okay? External secant segment. All right. Let's go ahead and get started then. So we're labeling page number 15.4 on page 130. I just now realized that I don't understand how I did this. I should have 15.5 here, and I don't know what happens. We're going to have to add a little blank in the next video. So 130, and there's nothing on, that's not on 131. So I'm going to go ahead and write that. We're going to have to add 15.5 here, which does exist, which is angle relationships. I don't know how that happened, but it did. I have to make myself a note to change this. Fix for next year. All right, we'll come back and label that in a minute. Not in a minute, in the next video. Okay, so let's go ahead and turn to page 130. We'll do that in, then we'll get started. Page 130, 15.4, segment relationships in circles. Okay. Fold this. Not this one. Found the other one. I didn't bring it with me, evidently. Okay, the segment relationships, chord, chord, secant, secant, and secant tangent. You have this handout. We're going to cut it, so it's got 3 flaps. I'm going to cut base on the inside because sometimes they didn't line up, and I don't wish they did, but they don't. Okay, we're going to glue that to 130, and then we're going to get started on the chord product theorem. All right, let's get started on the chord product theorem.
The chord product theorem states that if two chords intersect inside of a circle, let me get that so you can actually see it. If two chords intersect inside a circle, then the products of the lengths of the segments are equal. So here is what that means. Since these two intersect, the pieces that are created, AE, times EB is equal to CE times ED. That is the chord product theorem. So we're going to look at number 1. Notice you're multiplying the pieces on the same chord, and those are equal to the other pieces on the same chord. So number 1. How are we going to find X, which is what BC is? 2 times 4, because those two are on the same chord, equals 8 times X, which is just 8X. So 2 times 4 on the same chord equals X times 8, or 8 times X. What is 2 times 4? 8 equals 8X. So what does X equal? So what is AD? The whole chord, AD. 6. What is BE? The whole chord? 9. Do number 3. This is 2.4 for both of these chords. This is 7. This is Z. So both of these are 2.4. So what did you guys set up if you set something up? We'll talk about what you didn't have to do, but 2.4Z equals 2.4 times 7. What is 2.4 times 7? 16.8. Divide by 2.4 and Z is? They should be equal. Why? They're the same thing. 2.4 and 2.4 means it has to be 7 and 7. What is PS? What is RT? Now, they're not always equal. We saw that right here. But sometimes they are. That is the chord product theorem. We're going to talk about secant next. So open that one. Okay. The secant product theorem says if two secants intersect in the exterior of a circle, So the secants are intersecting out here. Then the product of the length of one secant segment equals the product of the length of the other secant segment and its external segment. That sounded like Greek, didn't it? Here's what it is, though. Let's put it in terms we will understand. AE, which is this whole piece, times the external segment, BE, is equal to CE, the whole secant, times DE, the outside piece. I like to write it like that so that I know it. You have to memorize these. Here's how I like to remember. Whole times outside equals whole times outside. Of course, the theorem is in real mathematical language. It says the secant, which is the whole, times the external, the outside piece, is equal to the whole, the secant, times the outside, which is the external. That's what that theorem is saying. But I remember it as whole times outside equals whole times outside. Which means sometimes we're going to have to add things together to find the whole thing. You always have to have the whole piece in order for this to work. So we're going to look at number 5. Do we have the whole secant on either of those? Do we have it just given to us automatically? No, we're going to have to add. Let's do that before we even worry about our problems. What is BD? Yeah, 4.5 plus 5 is 9.5. How about FD? X plus 5. We always need to find the entire secant length first. Okay, now we need to solve for x. It says the theorem is the whole thing, 9.5, times the outside piece, 5, is equal to the whole thing, x plus 5, times the outside piece, 5. Now we're going to solve that. So whole times outside equals whole times outside. Alright, what is 9.5 times 5? Okay, divide by 5? Okay, you can do that. If you didn't, if it didn't have a 5 and a 5, when you multiply, make sure you distribute the 5. But you can do this as well. It makes it faster. Yep, some people didn't need to do an equation. You realize, wait, since it's 5 and 5, these two have to be equal. So then, what does that leave x to be? 4.5. Okay. BD we already found. What is BD? And FD? Try number 7. Okay, so first of all, though, let's find the entire piece. What's 14 plus 4? And how about this? Z plus 9 or 9 plus Z, it really doesn't matter. Alright, what am I going to set up? 18 times 14 equals 9 plus Z times 9. Now, did you multiply or did you divide by something? You could have divided by something or you could have just distributed. Let's multiply. What's 18 times 14? 252? equals, what's 9 times 9? 81 plus what's 9 times z? Okay, then what'd you do? Subtracted 81. What is 252 minus 81? 71 or 9? 1. That's equals 9z. Then what? And z equals 19. You could have divided by 9, by the way, and not distributed, but it's probably about the same amount of work. Yes.
I didn't do the plus like 9 plus z. I started 9 and then whatever I got subtracted 9 from it because
You can do that. You still got the same thing, didn't you? Yeah. As long as you take care of it eventually. Alright, how about SQ? We already found it, actually. 18. How about SU? Okay, 28. Alright, last we're going to talk about the secant tangent product theorem. The secant tangent product theorem, we have one secant, we have one tangent. If a secant and a tangent intersect in the exterior, which is the only place they can intersect because, well, you know, tangent never goes inside. Intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external secant equals the length of the tangent segment squared. Well, the first part of that is exactly what we just talked about. The whole piece here, the whole secant times the exterior secant segment equals the tangent squared. Because we've had two pieces so far with all of them, and since we don't have two, it's got to be that piece double. Well, not double, but square. Now, why it works out that way, I don't know. I need to look. Alright, so, in case you need that little trick there, you've got whole, not trick, but just some way to remember it. Whole times outside equals tangent squared. The tangent segment that means sometimes you're going to have something to factor, which means if you have to factor today in your homework, we're going to go over it tomorrow. I have to remember and look what number you might have to factor. You might have to, yeah. You might not remember. We'll go over it. I'll look and see in just a minute if we need to go over one. Alright, number 9. First, we need to know what the entire secant is. And what is the entire secant? Ki is the whole secant. This is 0.5 plus x. Alright. We are going to set up the whole thing, 0.5 plus x, times the outside, 0.5, equals, what's the tangent? 1 squared. Which is 1. Yeah, 1 squared is 1. Now, I need to distribute that 0.5. What's 0.5 times 0.5? 0.25. Plus, what's 0.5 times x? Okay. Now, subtract 0.25. And you're going to get... So 0.5x equals 0.75. Divide by 0.5. X equals 1.5. Now you need to find IK. Two. 1.5 plus 0.5 is 2. Try number 10. That does say 51 over 7. Y'all, nope. Nope. Okay, how do I change this 7 to have a common denominator with the 51 over 7? It's like multiplying 7 over 7, right? Which is 49 over 7. So this whole thing here, what is 49 over 7 plus 51 over 7? 100 over 7. Alright, that, it is going to kind of go away in a minute. That'll be nice. Not go away, but you'll see what I mean. Alright, I'm going to work this over here. The whole thing is 100 over 7 times the outside 7 or 49 over 7. It really doesn't matter. Actually, it will, and you'll see why. Equals, what's the tangent? Y squared. What is 100 over 7 times 7? 100. That's why it helps out. Those two cross out. They cancel. Okay. What is, how do I solve this? Square root. If you remember from algebra, it's good to know. Technically, this would be two answers, positive and a negative 10. Why do we not want the negative 10? It's a side length, but you need to know it still exists, because when you get to algebra 2, don't tell your teacher, I forgot that there was a negative 2, because I've been telling you there is this whole time. Y equals 10. What is Km in a fraction? We already found it. 100 over 7. Or, you guys said it's also what? 0.2. Okay. Here you go. Glue this in.